Hey guys, welcome to this video where I'll be talking about the difference between theoretical and actual yield. Let's first talk about what the word yield means. So in simple terms, yield means the amount of product that you get from a chemical reaction. So in the case of our combustion reaction, it would be the amount of CO2 that we get or the amount of water that we get. So now let's move on to what theoretical yield means. Theoretical yield means the amount of expected product that you're going to get from a reaction between your two reactants. So amount of expected product. But more often than not, you're never really going to get the amount of expected product that you calculate in your stoichiometric calculations. And that's where actual yield comes from. Once you do the entire lab and you perform the laboratory experiment, the actual yield is the actual amount of product that you get from a reaction. One thing to note here is that your actual yield will always be less than your theoretical yield, no matter what. And this is because of a few reasons. One reason could be because of impurities in your reactants. For example, if we go to our first equation here, we could be reacting with not very pure methane. There could be some other elements mixed in with your methane. And so you're never going to have that perfect reaction between methane and oxygen. So let's go back down here. Another reason could be because of some side reactions. And this could be because of impurities, because if you have methane reacting with something else that's not pure oxygen, that could cause some other types of products to be formed that are not the products that you're looking for. Another reason is quite fairly simple, is that when you're weighing your beaker that you're performing the reaction in, some of the product could be sticking to the side of the beaker. So when you're weighing it, you're never going to get that exact amount of product that you're looking for. So that's another fairly simple reason why your actual yield could be less than your theoretical yield. The final reason why your actual yield could be less than your theoretical yield is because the reaction could not have fully gone to completion. Your reaction could have stopped halfway, and it probably couldn't have gone 100% to the end and produced all of the product that you were expecting. It could have stopped halfway and you would have gotten only half the amount of product that you're expecting. So these are 4 reasons why your actual yield could be less than your theoretical yield. So now let's go ahead and work with the question that deals with theoretical yield. So above we have the combustion reaction for methane that we've had for the past few videos. The question says, if 8 grams of methane are reacted with 10 grams of oxygen, how many grams of carbon dioxide will be formed? So essentially this question is asking us for the theoretical yield of carbon dioxide. At the same time, it's also a limiting reactant question because it's giving us the 2 different weights of both our reactants. So we have to perform 2 separate dimensional analysis for each reactant. If you are a bit unsure on how to solve for the limiting reactant, I highly recommend you watch one of my previous videos where I talk about that concept. So first, we need to do a dimensional analysis on the 8 grams of methane to see how much will be produced. So 8 grams of CH4, and we need to convert that all the way into grams of carbon dioxide. So first we need to go from grams of carbon dioxide into grams of methane into moles of methane. 1 mole of methane is approximately 16 grams. Then from moles of methane, we need to go to moles of carbon dioxide. So in this reaction, every mole of methane yields 1 mole of carbon dioxide. And then finally, we can go from moles of carbon dioxide to grams of carbon dioxide. So for every mole of carbon dioxide, we have 44 grams of it. And so now all we need to do is just perform the calculation. So what we need to do is 8 times 44 and then divide that by 16, and that gets us 22 grams of CO2. So that's the first amount of product that we get for our first reactant, 8 grams of methane. Now we need to do another dimensional analysis for the 10 grams of oxygen. So let's go ahead and do that right here. We have 10 grams of O2, and we need to, at the end of this dimensional analysis, get 2 grams of carbon dioxide. So 10 grams of O2, we need to go to moles of O2. So 1 mole of O2 is approximately 32 grams. Then for every mole of O2, we need to go from moles of O2 to moles of carbon dioxide. In the reaction above, for every 2 moles of O2, we get 1 mole of carbon dioxide. So I'm going to write that down right here. So 2 moles of O2 yields 1 mole carbon dioxide. And then finally, we can go from moles of carbon dioxide into grams of carbon dioxide. So every mole of carbon dioxide yields 44 grams. Now all we need to do is perform the calculation. So that is 10 times 44 divided by 32 times 2. And that gives us 6.875 grams carbon dioxide. So by a long shot, our limiting reactant is the 10 grams of O2. So in the end, we will produce 6.875 grams of carbon dioxide, and that is our theoretical yield. So now we have a follow-up question that states, what is the percent yield if 5 grams of carbon dioxide were produced in this reaction? So the percent yield is just a formula that compares the amount of actual yield to the theoretical yield. And that formula is actual yield divided by theoretical yield multiplied by 100. And the resulting value should be some type of percent. So let's go ahead and calculate the percent yield for this problem. So we're given the actual yield, which is 5 grams in this case, and we're told by the formula to divide the actual yield by the theoretical yield, and our theoretical yield we just calculated right here to be 6.875 grams. So I'm going to write that down here. 6.875 grams. Next, we multiply all of that by 100, and you should get 72.7% as your percent yield. So that wraps up this video. I hope you enjoyed it, and I'll see you in the next one.